Okay, hello everyone, my name is Rich, and today I'm going to talk to you about clean architecture. Now, there's been a lot of buzz in the Android community over maybe the last 12, 18 months, as we've been looking to improve the architecture as the Android apps become larger and larger. So recently, myself and my colleague Eric rewrote Messenger for our application, and we did this using clean architecture. We released an open source project based on it as kind of reference guide, as well as a way you can integrate chat into your app. So what I want to talk about today is, why is architecture important? Why does it matter? What exactly is clean architecture? A possible implementation, and what we learn from actually implementing clean architecture in our app. So to start off with, what is our app? So I work for a company called Badoo. We're an app for meeting new people. We have over 100 million installs. We're in 190 countries. We have over 100,000 lines of code. So it's a massive code base, and it's getting interesting to manage. So we looked at rewriting chat because it's sort of integral to our application. But over many years of extension, it was beginning to feel the strain of new features being added. So we wanted to do it in a new way, in a way that was maintainable, and a way that would allow us to add new features quickly going forward. We're just about to finish the integration into our core product now, and it's been an interesting experience. So why do we care about architecture? Now, architecture can be quite a dry subject. It's not maybe that interesting. People, when they start writing an app, want to basically start writing an app. That's what people enjoy. So sometimes the thought doesn't go in at the beginning. So quite often at the start of development, an app will start off quite simple. This is a fairly simple example of an app. It's just displaying some stuff from the network. And then as things go forward, you start to add some other features. In this case, we've added a cache because we want to be more responsive. However, if we're not thinking about the architecture of the app at this point, things start to get out of control. And as we go on, we can quite easily end up with something like this. It's difficult to maintain, it's difficult to add new features, and testing is pretty much impossible. And when you get to this point, you kind of realize that you've made a huge mistake. So when I was researching stuff for this presentation, I found this expressed in quite a nice way. And that was in the form of technical debt. So whatever your app is, you're always going to have some level of technical debt. The idea is to keep that as a small and manageable concern, rather than letting it get out of control. So you want it to be something like this. You've got little things that you want to fix, but at the end of the day, it's not causing you any nightmares. However, if you don't have a good architecture, things quite quickly get like this. And it comes to adding new features. You don't know what, you're worried about adding new features, it's going to be difficult to fit them in. You get a bug, it's an absolute nightmare to find because you're debugging through loads and loads of code, and you just don't know where things should be. So, this being said, what is clean architecture? So Uncle Bob came up with this as kind of, I guess, like an expression of intent. That is, a good architecture emphasizes the use cases and decouples them from their peripheral concerns. And what he means by this is, it's about what your app does, not how it does it. So whatever you use, whatever frameworks, they're just a peripheral concern. It's about the actual business logic of your app, what it does. So, clean architecture. Like I mentioned, it was coined by Uncle Bob, or Robert C. Martin, and it was kind of taking together various ideas that are kind of out there in the community and have been out there for a long time. I'm not going to go through all of these because that would be enough to fill many presentations, but I'd suggest if you're interested, you go to his site afterwards. You'll have a look at hexagonal architecture, is quite interesting, and his blog post on screaming architecture. So, what are the key points of clean architecture? Clean architecture is focused on the use cases, the business logic of your app, not anything else. That is the important part of your application. It's focused on the structure, what your package structure of your app is. You should be able to look at your app and understand what its actually intent is. The dependencies should face in a single direction. They shouldn't be cyclic, and it should be very easy to see where things go. You should have different models depending on what part of your application it is in. So in the view, you're going to have things to do with presentation, maybe item space and something like that. This logic isn't something that you want to be persistent in your data layer, or it's even something that the use cases care about. Finally, it should be testable. I mean, this is one of the key things that we've gained from using clean architecture, is it's very easy to test things, and that's mainly because a lot of it is just Java code and it doesn't really have many dependencies. So, what is a use case? So I'm sure most of you have heard of a use case, maybe some of you have used UML back in the day, and basically a use case captures a business rule. So for example, say Bob wants to send a message to Alice. Sending a message is the use case, and it's pretty much as simple as that. However, if you think of what would actually happen when Bob sends a message to Alice, maybe he enters some information in a text box, you click a button, it gets sent. That's the implementation detail. You don't worry about that as part of the use case. It's just simply what you want to do. And the reason for that is it could be different ways to send a message. So for example, in some apps now you have automated responses. And that would still be using a send message use case, but it wouldn't be using the implementation I just talked about. So what does it do? So this is talking about the structure of your application. And a really good way I saw this expressed was talking about looking at blueprints for a building. If you look, for example, at the blueprints for this building, you could probably tell it's intended for conferences. It would have different rooms marked as conference rooms. It'd be pretty clear from the blueprints what it does. And the same if you looked at the blueprints for a church. You'd be able to see it was a church, and you'd be able to see the difference between them, and it'd be very clear. Now, I've seen many applications written like this, and I myself have written many applications that look like this, and it doesn't tell you anything about what the app does. You can tell it's an Android application, it's probably using MVP, but no one's got an idea what it does. If you look at something like this, you could see that's probably an application to do with chats. It's got something to do with conversations and chat. It's very clear. You've got no idea how it's implemented. It might not be an Android app, it could be absolutely everything. But it's clear what the intent is of the app. So dependencies. This is kind of like, I guess, a very classical diagram of an application architecture. You've got your business logic sandwiched in the middle between your data and your UI layers, and you have infrastructure off to the right. And kind of everything is indirectly dependent on everything else. It's very difficult to kind of make changes. If you wanted to take something out of your infrastructure, you could quite easily affect all your layers. The same way the data layer is kind of indirectly bound to your UI layer, and obviously this is not something we want. So with clean architecture, we end up with something like this. So in the center, there is the use cases, the core of your application. And this doesn't depend on anything. It is pure Java. It's just expressing the business logic of your application. On the outside, we have the kind of implementation details. So stuff to do with the user interface, the HTTP protocol you're using, or if you're using a database or whatever, it's just all pushed to the side. And then you generally have a mediating layer that allows data to flow between the two. But the importance is the dependencies face inwards. So in the case we talked about where we were sending a message, it would go through the UI to the presenter to the use case. However, if the use case can't depend on the outer layers, how can the use case actually send a message? And this is done by something called inversion of control, which I'm sure many of you heard of. If you haven't, classically, you'd have something like this, where class A depends on class B. Inversion control reverses this. So class A would define probably an interface, class B would be an implementation of that interface, and it would be injected into class A. And what this allows us to do is quite easily change the implementation. And the class A in that case would know nothing about the actual implementation. So, as we were talking about sending a message, we could have an implementation that sends it by a carrier pigeon. Or probably more usefully, we could have an implementation that uses HTTP. So why do we have different models? So if you think of it in terms of wine, at different stages of production, different models make sense. So at the vineyard, it doesn't make sense to think of it in terms of bottles. makes sense to think of it in terms of grapes. At the end user, it makes sense to think of it as a bottle. You're probably not going to be thinking about it as barrels, and you're certainly not going to be thinking about it as grapes. So how does this look in an actual application? So if you go back to the message example, at the use case, it's quite simple. We just have the message, its ID, and who it's from. At the data layer, we might have something to do with caching, how long that message can be cached for. It doesn't make sense to have this at the use case level, but it makes sense at the data model. And then finally, maybe at the view model, we have something about item spacing or something like that. Now, this is not to say that you shouldn't share models, because if your model is the same across all those different layers, it makes no sense just to copy it just for the sake of making sure you have a different model. However, as soon as you kind of feel that things are starting to diverge, that's the point where you should start pulling these models apart. So if you start off and then you realize at your view level you want to have item spacing as part of that model, you don't want that in your use case. So that's the point where you should split off and start using a separate model. So how does this all fit together? So we end up with something that looks kind of like this. So at the center, we have the use cases, and we have something that are called entities. Now, entities are generally going to be kind of just simple Java models. In presentations that Uncle Bob does, he talks about entities containing enterprise business rules. So they're the kind of things that if you had many different applications and you had some business rules that were used across all of them, you'd probably put those in the entities. However, in Android, there's not that many apps that would need to have that. It's kind of, these end up being kind of just normal, simple Java objects. Again, we have the use case, and this can manipulate the entities by using this gateway interface. So this is an entity gateway. And the importance here is all of this is just pure Java. There's no dependencies on any frameworks here. There's no dependencies on anything. So it's very easy to test. And that's at the core of this. It's your business logic is so simple to test. You don't have to worry about mocking all sorts of different things to do that. So at the presentation layer, we're using MVP. You could use MVC or MVVM, it doesn't really matter. It's just some kind of presentation pattern. So for those of you who aren't aware of MVP, it's basically you have a presenter that mediates between the view and the model. So if the user clicks on the view, the presenter would then take that action, it would interrogate the model, make whatever changes, get the update, and then turn whatever that update is into a presentable thing to pass back to the view, which then obviously the user would see. One thing that I do see is like people talk about kind of MVP as an application architecture, and it's not, because you end up with this model, and the model is basically the rest of your application. It's a great way for doing presentation, but it's not a great way to kind of architect your app around. However, if you are using MVP, it's kind of easy to move to clean architecture because you already have your view logic separated. And then finally, we have this gateway implementation. So this is a way that you can actually manipulate these entities. So depending on how complex your app is, you may have different levels of caching. You probably have something that calls to the network. And one of the great things about this was by the fact that the entity simply defines an interface and defines what you need to do. When we were developing the kind of messenger project, we started off and we just had like something that returns simple Java objects. It didn't talk to the network. It didn't do any caching. And then as we moved forward, we actually integrated with the network. And then finally, we were able to make the decisions about whether we wanted to actually do caching on certain messages and how we wanted to cache. But we were able to defer those kind of decisions right to the end. We didn't have to worry about it when we started, and we could develop the kind of business rules, and we could develop the UI completely independent of this. So, how does this actually kind of fit together and work? So say, for example, Bob, he's back again. He wants to open a conversation. So he would interrogate the view and say, I want to open a conversation, which would in turn go to the presenter, which would then call one or more use cases. Now, quite often you'll find that maybe it's a one-to-one relationship between something happening in the view and the use case is invoked, but other times you'll find you'll have more complex interactions. So you may have a use case that's a composite of multiple use cases, or the presenter might actually interrogate multiple use cases. And then this talks through the gateway to try and retrieve the entities. And it'll check the memory cache in this example. If there's nothing there, it'll then check the disk cache. And if there's nothing there, it'll finally go to the network. And hopefully that information will be there. And then, obviously, it gets passed all the way back through until finally Bob gets his list of messages. So, implementation details. How did we actually do this? So, to start with, this is what our message gateway looked like. So, originally we tried to kind of use a repository pattern for this, and we kind of had this simple CRUD operations, and we had queries. The problem we had with that is it got out of control pretty quickly. We had all these queries that had multiple fields on. It didn't really make much sense, so we tried to be more verbose about it. So it's quite clear here. You can see you can get messages, you can send a message, you can delete, and you subscribe to updates. So the callback would then return some information about what actually updated. The use case for getting messages would be pretty simple. It would simply talk to the message gateway and ask for a list of conversations. However, you may have use cases that are more complicated, and that's probably going to be the case. So for example, you might have something like this, where initially you send a message, and then if it's successful, maybe you want to update the conversation. So it knows it's been updated, it knows that there's a new message there, it wants to display that on a different screen or something like that. It's able to actually indicate that that's happened. And then finally, at the presentation layer, we have something like this. You send a message, there's an error, you display the error. Now, one thing that you'll notice that's kind of absent from this is any form of threading. And that's kind of intentional at this point. We originally tried to do this through using a series of callbacks. And it worked, but it got messy very quickly. So every use case would end up with some kind of callback. And as you can imagine, the amount of use cases grew pretty rapidly and it became difficult to manage. So for threading, we had a look around and we looked at RxJava. And now obviously this isn't an RxJava talk, but I want to show you a quick example after this of why we used it. But mainly, it made it simple to switch threads. It was quite easy to just say, I want this to happen on the background thread, this to happen on the main thread. And also, the transformations between models became quite easy. So when something was returned from a gateway, it could be quite easily transformed in the kind of stream of events going back. It did come with a bit of a cost. RxJava's obviously got a steep learning curve. It was mine and Eric's first experience of it, and at the beginning it was pretty tricky, but I think it worked out pretty well in the end. So just as a quick example, without RxJava, you might have something like this. It's a bit of a convoluted example. I'm sure you could do something a lot neater and tidier than this, but it kind of gives you an idea. So you want to do something in the background. Once it's complete, you then publish the result on the main thread. And obviously we can clean this up a little bit by using lambdas. So it's still pretty nested, not great to read, but with RxJava, we can end up with something like this, which is obviously very easy to read and just nice and simple. One thing we did do is at the gateway level, we did all the kind of background threading. So the presentation layer would always observe on the main thread because it doesn't know if the result's going to come back on the main thread or whether it's going to come back on a background thread. We originally looked at maybe doing this around the use cases. So the use cases did this, but the use cases should be simple. They shouldn't have any knowledge of threading. They don't care about it. It's about business logic. So how did this all, well, Rx was very nice. And how did this all look? So one thing we did do is we use singles to define things where there's a single result. For those who aren't aware, the difference between an observable and a single is a single returns only one event and exactly one, an observable can return 0 or more. And the reason for this was, if you had something that was intended to return a single result, it didn't make sense to kind of say, oh, that could return 0 or many, because you want to rely on that single result. It made our use cases, again, it's pretty simple, the same as before, and it didn't change much when it came to the more complex use case. And then finally, at the presenter, it was quite easy. We observed on the main thread, and in this case, in the result of an error, we display an error to the user. It did make caching quite easy to do, so we could chain together these calls. So if we wanted to load something from memory and then we wanted to go to a database, we could start off, we could try and load something from memory, and if it fails, if it's successful, we can return it. And if it fails, we can load it from the DB, and we could chain this down so it goes to the network as well. So, was it worth it? Well, to start with, we did find there was a lot of boilerplate code that we had to do, especially at the beginning when you were adding a new gateway, and you had to add all the use cases and the presenters all the way through for it. It was a bit of a pain. However, as the app, as we developed the app further, most of those kind of things were already in place. So when you came to add a new feature, it was generally a lot easier. You just had to add whatever use case, or use the use cases that were there, and then finally add the new presentation logic. The learning curve was fairly steep. We kind of watched a lot of presentations, read a lot of blog posts about it, and you kind of think you understood it, and then you'd read something and you'd be like, no, I didn't get it at all. So it took a while to actually get to the point where we felt more confident using it. However, from Advantage's point of view, testing was now really easy. I think in the open source project we had around 60% testing, which was far greater than we had in the rest of the application. Everything had a place, so when you come to implement a new feature, you know where things should go. You can pick and say, right, it's something to do with caching, it should go in the data layer. It's something to do with manipulating data for presentation, it should go here. Whereas previously, if we had an app where everything was kind of entangled, it was never that clear. And finally, well, actually not finally, but kind of finally, decisions could be postponed and implementations were replaceable. So as I talked about, when we started off with just an implementation returning simple Java objects. As we moved on, we changed that and we integrated the network, and then finally we integrated caching, and allowed us to kind of not worry about those decisions till right near the end. So if you want to use clean architecture, what can you do? So one thing we did learn is start small. In hindsight, starting off on such a big project was very ambitious, and it was pretty tricky. If I could do it again, I'd probably start with a little small project and just play around with the concepts and kind of get a lot more familiar before trying to do something so large. Discuss and experiment among your team. So this all started for us when a member of our team, Mike, he went away, he read up on clean architecture, and he brought it to the rest of the team and said, hey, I found this way we can do things. What do you think? And we started to experiment with it and decided, yeah, that seems the right idea, and it seems like something that's good, and it had a lot of advantages. We have tech talks internally, so every 3 to 4 weeks we would present what we were doing on the Messenger app and how we're using clean architecture. And that was good for us as well, because we get some feedback on decisions we'd made, where we'd filled in the blanks to make sure it kind of made sense. We did code reviews. Well, we do code reviews anyway, but generally we just do a single code review unless it's some complex code or it's something to do with billing. However, when we started to bring new members onto the Messenger team to do the integration, we did 2 code reviews. So me and Eric would do a second code review just to check everything's okay, but we'd get people to code review each other's code, and that definitely sped up the learning speed for everyone who came onto the project. So, in summary, I think clean is good. It was worthwhile doing. I don't think there's one correct way to do it. So if you go away and you kind of start doing things, but you do things that look slightly different, As long as you're following the kind of key principles, you're on the right track. And if you want to look at our open source project, you can find it at the top, our tech blog, and my details at the bottom. And then any questions?
I had a question.
Yeah.
So I think the clean architecture sounds really cool.
Yeah.
And the idea of having use cases very separate from the implementation is nice.
Yeah.
But it seems to me there's going to be cases where you need to know what the implementation is. So for example, like, yes, sending a message should be like agnostic of how that message is sent. It could be like a marathon runner, it could be whatever. Yeah. But like, since we're on phones, it's nice to know whether like the user has any internet connectivity at the moment. It's like, how do you, so like you might want to show like this message is not going to send right now because we're not even going to try because there's no internet.
Yeah.
So how do you like architect around that without like getting things getting really ugly?
So yeah, it's an interesting question. So I guess in the example you gave of sending a message, you would need to know something about kind of what the device was, kind of so you work on the phone. So what we've done in that case is when you send a message, it kind of attempts to send it, and you get like an error message back saying there's no network connection. So it would actually go through all the various layers, but it would just return kind of straight away. One thing we've kind of had a lot of discussion about is dealing with stuff like offline chat. So is the fact that you have kind of like persistence of offline messages, is that something that the use case should know about, or is that something that just the kind of gateway implementation?
Yeah, because like, do you show on the UI that like it hasn't sent yet or something like that?
Well, yeah, I mean, you'd show that it hasn't sent, but it's just kind of like dealing with that, the logic of like kind of offline messages. So like, should it be that the use case tries to send a message, it gets an error, and then it tries to use a different sort of gateway that deals with persistent, or should that be just completely transparent and he just gets an error message back? And so that's something we've kind of, I haven't got an answer for. It's something we're actively discussing. We'll probably make some changes based on what we decide. But yeah, it's an interesting question, and it's hard. I don't think there is a right answer. I think you can kind of do it in both ways, and it can still be okay. But yeah, it's a difficult question.
So toward that, to what you said, Realm just released a kind of cloud-based thing where they say basically you never have to worry about network programming again. And you know, there's the 7 pillars of distributed computing. Like, you have to think about the fact that you actually might get latency and might get timeouts and all that kind of reality. But there are models you can use to say, well, I'm going to deposit this in my repository, and I don't care if the repository is local or network or whatever. And as long as you kind of do a good enough job abstracting all the possible kinds of error conditions that might happen, the state machine is complete, then maybe you can kind of get halfway there. So I haven't looked at that code yet, but that might be interesting to check out too.
Okay, cool.
Yeah. I have one question in particular when trying to sell clean architecture to a team. How do you push back against arguments against clean architecture? Primarily arguments such as we can't do clean architecture because our apps are too simple. You know, this is something that I personally dealt with, where certain colleagues of mine have concluded that implementing something like MVP might be it's overkill for the types of apps that we create, even though as of right now our code isn't. I can't really say that it's clean.
It depends, because like it depends what the app's going to be. I mean, if you can guarantee that it's going to be a really small app, maybe something like using clean architecture is going to be overkill. But then again, on the other hand, if the app is going to be really simple, well, the use of clean architecture should be really simple as well. So it shouldn't actually cause you that many problems.
The types of apps we're talking about are like, they're, to give you a little bit of context, they're retail apps. So things like user trying to look at products, do check out from there. So that, all right, maybe I'm not phrasing it properly in terms of the fact that they're not simple, but that they might be simple, but in the same token, I think they're somewhere between simple and complex.
Yeah, I think the difficulty of actually using something like clean architecture on a small app isn't that great. And if that app grows, the cost you'd pay for not having, I guess, any architecture, not necessarily clean architecture, but any sort of application architecture at that point becomes quite great. So it's kind of, I guess you can try and sell it as an insurance policy. That yes, at the moment it feels a little overkill. It shouldn't cause you that much trouble, but the cost of not doing it at the beginning, and the app grows and grows and grows, and you end up in a situation where you've got some kind of spaghetti code and it's very difficult. So
I've dealt with that personally as of the past couple of days or 2 weeks, past couple of weeks, having to deal with legacy code in order to work around it, not trying to create landmines or step on them.
yeah, I mean, I guess what you could do as well is maybe just create a simple implementation using clean architecture. I'm not saying rewrite completely another app, but kind of take a part of it, do it in a way that you're happy with, and then kind of present that and say, well, look, it's not actually that much extra work, and the rewards for doing it in the future could be a lot greater.
Right. Thank you.
Yeah.
Is there any reason not to ensure that your gateway is always returning data on the main thread, and instead of observing them on the main thread in the presenter layer?
Yeah, I guess you could take either approach, to be honest. The reason we did it kind of that way was because it didn't put any. We didn't say how the gateway should work. We didn't put that kind of rule on them, so they could return anything they wanted. If you, in your app, said, right, everything at the gateway level has to return on the main thread, that would work as well. But I guess the difficulty is if the presenter you're kind of explicit, you want that data on the main thread. If someone messes something up and they start not returning data on the main thread, you kind of protect it for it. It's I don't know. I guess you could do it either way.
It sounds really counter to clean architecture, though. Like,
What do you mean?
Because now you have like UI concerns, like you said before, that are like further down in your architecture. So that surface layer is where you're concerned about what thread you're on to present something to the user. And as soon as you tell the next layer down, hey, the UI wants stuff on the main thread, like you just kind of undermine it.
So
Or one of the core tenets,
I guess-
I feel like.
I guess the way I would kind of think about it is, I wouldn't think about it as returning on the main thread. I would kind of specify that you return on this thread. It doesn't need to know it's kind of like the main thread. So we've got it. So we specify, right, this is a scheduler that we want you to use for network calls, and this is a scheduler we want you to use for database calls. So I think we use like a single scheduler for all the database calls, and then there's like a thread pool to the network. So it's kind of, I see what you're saying. Like if you said explicitly, I want it to return it on the main thread, it does seem a bit weird. But if you're kind of just saying that here's a thread I want you to return on.
Yeah, but I mean, if you're in the RX and you're at that lower layer and you're saying like, return on main thread, or then that really doesn't feel right at all.
So yeah, I mean, like I say, we wouldn't actually
Or observe on
put
main
in
or
like
something. Yeah.
the main thread. We just say we return on this scheduler kind of thing.
Yeah, that makes sense.
What line do you draw for use cases? So take like the idea of you click on a person and you show your message list or your chat with that person. Is that a use case, or is that something that you just hide in the UI?
Right, so you click on a person and you show an image. So
Or your conversation with that person.
yeah.
Right.
So I guess in that case the use case would probably be just the retrieval of that person, and then all the information about displaying it would just be the presentation kind of thing. So you click on someone, you'd have a use case, maybe get person or something. I want to get a person. That would just simply retrieve that person, and then all the stuff to do with the presentation would be in the presenter.
Okay, so the presenter would probably be the one that would be telling the view, hey, you should switch from showing
Yes.
a list of people to showing your chat history.
Yeah, so I mean, maybe it's like a segue, but it was kind of interesting trying to deal with differentiating between changing screens in Android, because obviously that's very tight at the kind of activity level. And what we what we ended up doing was kind of allowing the presenters to have a way that says that they need to do something, but they're not responsible for it. So something like switching conversations. And I'm not sure if it's completely the right way to do it. It's something we're still kind of discussing, working with. But we had like something called like a kind of flow listener, which was passed into the presenter, and the presenter was at a point where he couldn't do something. So say a conversation was clicked and it's conversation list presenter. It's not responsible for showing that conversation detail, it's just there to present the conversation list. So we would say to the flow listener, conversation requested or something, and then that would then open another set of presenters which would deal with a different set of details.
It's quite like an intent.
Yeah, and it's kind of just like moving an intent out of the presenters, just a testing point of view. Cool. Anything else?
So were your, kind of following on that, were your gateways very card feeling then at that point? Like it mostly just dealt with like that low level of like concept of like the person or the product or the message list or the like retrieval and
Yeah, I would say they probably are, yes.
So I'm assuming you're familiar with the original article from Fernando around clean architecture.
Yes, yeah.
I'm wondering how much in implementing it yourselves you diverted from what he came up with. Like, did you follow the same like packaging structure, dividing the projects between domain and repository as separate Android projects, or keep them all into one, or?
So for the Messenger project, everything's in a single project with various kind of like top-level packages such as chat, conversations, that kind of thing. Fernando's stuff was actually, I guess, one of the first articles that was read to do with clean architecture, and I'd say, well, on Android anyway, it was what my kind of like inspiration from, and used to work with one of his colleagues, Fernando. So, yeah, I mean, I think things are reasonably similar to what he's done. I couldn't off the top of my head say exactly where we diverged. We probably have diverged in places, but where exactly that is, I couldn't honestly say it's here and here and here. But yeah, I mean, his is definitely a good example.
His plus the Google samples blueprints projects, they make, around clean anyway, they make some assumptions or decisions about how threading should be handled in regards to like scheduling your use case and that sort of. And I'm wondering where RX and threading meets, the road here with clean architecture, what you guys decided to do there. I don't know, I found it kind of strange with the way that they handle.
So they that's remember
Well,
they do it
like,
at the use case level, don't they?
Yeah, there's like a scheduled provider that's passed into the use case. And
so I mean, originally we did kind of we did look at doing the threading around the use case, and the use case was responsible for kind of going to a background thread and coming back to a main thread. But reading kind of like the intent of what clean architecture is, that did feel a bit weird that was having to deal with threading concerns, because you should be able to just take the use cases and put them in a completely different application. So one that's maybe one that's not concerned with threading at all. So then if the use cases are kind of tied to threading, and you can't do that because you have to take them somewhere which has that same threading model, which I think would kind of break some of the principles.
How do you deal with retying basically your view to your use case if, let's say, you have an orientation change, so like a long run task of like login or something?
So, I mean, the view wouldn't touch the use case, it would always go through a presenter. It's interesting. So we've tried to do some kind of caching of requests. So if you say I want conversations for this user. Something that kind of like the gateway implementation layer would say, well, I've already got this request in progress, so I don't need to fire off, I can just return the result from that request. So we kind of tackled it that way. I'm not sure if that's the best approach, but it's kind of the way we're doing it at the moment.
So if you have an Android system dependency that your gateway relies on, like SQL database or another database or properties or files, and you want to be able to run your tests as plain Java tests.
Yeah.
So how did you isolate those layers?
So you just, I guess in a similar way that the gateway to the interface works within, we've been injected, we kind of try and wrap those things in an interface. For example, dealing with the database, we'd just have an interface that does that interaction, and then at unit test level, we could just mock that, and then we could have an actual implementation in live. Cool. Well, thank you very much.